So there's this guy, and he wants to walk up this mountain. And he does. He starts at 8 a.m. and ends at 8:20. He spends the night camping at the top. And at 8 a.m. the next morning, wow, that's early, he goes back down. It only takes him 10 minutes for whatever reason. Maybe this dude has a snowboard, I don't know. But at some point on the way down, he goes like, I think I was in this exact spot at this exact same time yesterday. What are the chances? What? But what this dude doesn't understand is that the chances of this happening were 100% likely, which can be proven using the power of calculus. So we're going to have two functions, s of t and r of t, where t is the time, specifically the time in minutes since 8 a.m. S of t represents where our guy is on the mountain when he's climbing up, and r of t represents the spot he's at when he is going back down. You can think of the side of the mountain kind of like the y-axis, where the base of it is 0, and then the camp is some value k. It doesn't really matter what k is, though, but k is a positive value. So in order to be at the same place at the same time on both of these trips, the difference between s of t and r of t has to equal 0. Or in other words, there will be no distance between them because the place on the mountain is the same one. So we can set up a third function, f of t, to represent the difference between s of t and r of t. Since the shorter of the two hikes is 10 minutes, that means that we just have to prove that there's some value of t between 0 and 10 that would make f of t equal to 0. Let's start by finding f of t when t equals 0 and when t equals 10. Now to find f of t, we need to find s of t and r of t. So when t equals 0, s of t also equals 0, because when you have 0 minutes on your hike up the mountain, you haven't traveled up the mountain at all. And when t equals 0, r of t equals k, because when this guy doesn't start his walk down the mountain yet, he's still up at k, up at camp. That means that f of t when t equals 0 would be 0 minus k, which is some negative value less than 0, because we know that k is a positive number. Now we need to find f of t when t equals 10, so 10 minutes into both walks. So we need to find s of t when t equals 10 and r of t when t equals 10. Now what is s of t when t equals 10? We don't actually know that, but that's okay, and you'll see why in a second. R of t when t equals 10 is 0, because once he walks 10 minutes down the mountain, he's back where he started. So right at 0. So now we got s of 10 minus 0. The minus 0 doesn't mean anything, and we know that s of 10 is positive because it's farther up the mountain than 0, which means that f of 10 is greater than 0. So now we know that f of 0 is negative, and f of 10 is positive, which means that there's some value of t in the middle that equals 0, which means that we proved that this guy was right.